So we're going to talk about dilation and scale factor today. So during first semester, way back in first semester, we talked about some transformations. And we talked about three different kinds in first semester. We talked about a translation. We talked about rotation. And we also talked about reflection. Does anybody remember what was special about these three kinds of transformations? What did it do to the size or shape of the object we were working with? What is it, Sam? They stayed the same. They didn't change the size or shape. They just moved them around. So after we did translation and rotation and reflection, our figures were still congruent. So these transformations didn't change the size or shape. We're going to talk about, in this chapter, we're going to talk about a type of transformation that changes the size. And that's our dilation. Changes the size, but not the shape. Same idea. It gets bigger, but it doesn't stop being a circle. So this is the type of transformation that we're interested in chapter 8. So the first thing we're going to talk about is dilating a point. And the way we write it seems kind of strange, but it's really pretty straightforward. So if we have to dilate a point, we just multiply the x and the y by the same number. And the way we write that, and this is the part that kind of seems confusing, we say that D stands for dilation. The dilation of the point xy equals some number times x, and our y coordinate is some number times y. So n is just some number. And we call the number the scale factor. So we're just multiplying our x and y by the same number. And the scale factor is going to be one of our important vocabulary words in this chapter. We'll talk about scale factor a lot. So is everyone good with this? So let's look at an example of dilating a point. And sometimes the questions can seem a little strange, but we'll talk about what they mean. So we want to know what is the image of point 1, 3 after the dilation dx, dilation of x and y, equals 3x, 3y. And the image just means what do we get after we do the dilation. So what this is asking us, what happens to the point 1, 3 after the dilation 3x, 3y? And we also want to know what is the scale factor. Well, this dilation is just telling us multiply x and y by 3. That's all this is telling us to do. So our scale factor is the number that we're multiplying by. It's just whatever we're multiplying the x and the y by the same number, so our scale factor is just that number. And our dilation, and I'm going to write, instead of xy, I'm going to write 1, 3. The dilation of 1, 3 is just 3 times 1 for the x, and 3 times 3 for the y, and that gives me 3, 9. So that's all this question is asking us. Pretty easy. And if we plot, now the thing that's interesting about dilations, and I'm just going to do a quick sketch here. If we plot the point 1, 3, so this is over 1, up 3. I know it's not exact. And we go over 3 and up 9. So this is 1, 3. And this is 3, 9. If we measure the distance from 0, 0 to 1, 3, and we measure the distance from 0, 0 to 3, 9, the distance between 0, 0 and 3, 9 would be 3 times as big as the distance between 0, 0 and 1, 3. So dilations multiply the length of segments by the scale factor. So that's one important thing about dilations, is they multiply length by the scale factor. So this segment here from 3, 9 to 0, 0 is 3 times as long as the segment from 1, 3 to 0, 0. And dilations can make objects bigger or smaller. If our dilation, rather than 3, if it were 1/3, it would shrink the segment. The segment would be 1/3 the length. So dilations that make the image bigger are called expansions. So if the image is bigger, the dilation is an expansion. And if the image is smaller, it's a contraction. And the way we tell if our dilation is going to be an expansion or contraction is by the scale factor. If n, and we're talking about the absolute value, it can be positive or negative. If our number is bigger than 1, so 1, 2, 2.5, 5, 7.5, if our scale factor is bigger than 1, we get an expansion. And if our absolute value can be positive or negative less than 1, that means some kind of fraction, 1/2, 1/3, 1/4, 1/8, 2/5, something that's smaller than 1, we get a contraction. So depending on the size of the scale factor, we get an expansion or contraction. Any questions on this? All right, let's look at how we dilate an entire figure. You know how to dilate a point. We just multiply the x and the y by the scale factor. Let's dilate an entire figure. So to dilate a figure, we have to start with a point. And our point is called the center of dilation. You can think of the center of dilation as it's kind of like a lens. If you're taking a picture with your camera lens makes your image smaller. So your center of dilation is kind of like your lens. It's going to magnify or make it smaller. And we're going to we'll dilate a triangle. So for what we're doing here, our image is going to be our shape is going to be a triangle. And we're going to use a scale factor for this example. Our scale, and let me move this because I might need to draw there. Scale factor equals 2. So we start with a point called our center of dilation. The figure that we start with, we call the pre-image. Pre just means before. That's what we have before we do the dilation. Now what we're going to do is from our center of dilation, we're going to draw a line from the center through each vertex and extend it beyond the vertex. Like so. From the center through each vertex and extend it past. Now what we're going to do from here is I'm going to get a ruler. So there's my ruler. And I'm going to measure from the center of dilation to the vertex along that line. So from the center of dilation to this vertex is 1.12 inches. So I'm going to go to 2.24 inches. I'm going to multiply that distance by 2, by my scale factor. So I'm going to go along here, and I'm going to do 2.25. That's pretty close. And I'm going to draw a point right there along that line. And I need it to stay there. Doesn't like to draw near the ruler. And I'm going to do that for each point and each vertex. So I'm going to rotate this around. So this distance to this, from the center of dilation to that vertex, is about 2.12. So now I'm going to go to multiply that by 2 and go to 2.24. I'm sorry, 4.24, multiplying by 2. So, whoops, go a little further. And I'm going to draw a point there. So there's my point. And I'm going to do the same thing for the other vertex. Measure to the vertex, 1.75. So I'm going to go to 3.5 now, multiplying that length by 2. There we go. Draw a point there. Now get rid of this ruler. And now I'm going to connect, make sure these are on my line here. And I'm going to connect these new points. I want it in black. So there's my image. this length from the center of dilation to this vertex is 2 times the length from the center of dilation to this vertex. So I just multiplied all the lengths by 2. And what I would find, if I measured the lengths of the sides of the triangle, each side is twice as long as the corresponding side of the other triangle. This would be an expansion. So I did an expansion. Because my shape expanded, right? Now if your scale factor is negative and it wants you to draw the dilation with a negative scale factor, instead of going this direction, I would go the opposite direction. So I'd measure from here to here and then go the opposite direction 2 times that long if my scale factor were -2. So my image would end up being over here rather than further than our pre-image. So this is how we draw dilations of figures. All my lengths are multiplied by the scale factor. Questions on that? So chapter 8 is going to be all we're concerned about is what happens to our shape when we dilate it like this. What happens, we've already talked about the length. We're going to talk about what happens to the area. We're going to talk about if we have a 3D shape, what happens to the volume. We'll figure out how we know when 2 figures are similar. Can we figure out if one figure is a dilation of another? So that's what we're interested in chapter 8, is how do we figure out if this is done to 2 shapes? And what does it tell us if we know that one is a dilation of the other? What does that tell us about the 2 shapes? And just as a note, I'm just going to write here at the bottom that the length of each side is twice as long as on the pre-image. All right, let's look at one more example and then we'll be done for today. Let's say we have a dilation here. So I'm going to start with a segment. And here is my center of dilation. And let's draw this dilation and go like so. Make that a little more accurate like that. And we'll draw in our image. So this is our image. This is our center of dilation. And this is our pre-image. And this is 2 inches. And this is 5 inches. And our question is, what is the scale factor? So from this information, how would we figure out the scale factor? Anybody have an idea? What is it, Jay? 5 divided by 2. We want to know how many times bigger the image is than the pre-image. And we figure that out by dividing. So the scale factor is 5 divided by 2, and when we divide that out, we get 2.5. So our scale factor is 2.5. This segment is 2.5 times bigger than this one. So our scale factor would be 2.5. So this is an expansion by a scale factor of 2.5. So that's all we have to do if we want to figure out the scale factor. How many times bigger is our image than our pre-image? Now, if our image were smaller, Say we went the other way, say we turned it around and our image were 2 inches and our pre-image were 5 inches, then we'd divide 2 by 5 and our scale factor would be a fraction or some decimal. And then we would know that our image got smaller compared to our pre-image. Questions on that? Okay.